Hi everyone and welcome to this Year 10 lesson on surface area, prisms and cylinders. Yes, if you are in Year 10 and you are in Australia and you are following the Cambridge Essentials textbook series, then you are in the right place because this wonderful little box here tells you the type of questions that you should be looking to do. And if you're in my group, I am looking forward to you doing the advanced questions. But let's not do the enrichment questions. Hey, look, actually, if you want to do the enrichment questions, you knock yourself out. But most of you, I'm just asking for the questions up to including reasoning. We've dealt with measurement before, right? So it's really, really important. Measurement comes up throughout mathematics. Every single topic, geometry and measurement, you could pretty much argue is there. We've already missed, if you look at the textbook, and if we actually go back to where we actually started, you'll notice we start at topic 6D. So where on earth is 6A, B, and C? Well, there we go. Look, it was a recap. Those three chapters for Year 10 were a review of length, they were a review of Pythagoras Theorem, and a quick review of area. So I'm actually going to do that in this video. We're going to call this part 1, and then we're going to move on and actually do some of the exciting stuff in part 2. Otherwise, this video will probably be about 40 minutes long. And who's going to listen to me for 40 minutes? No one. Even I can't listen to myself for 40 minutes. All right, so let's do this recap. First things first, review of length. You have to be able to know how to convert between metric units of length, i.e. from kilometers to meters, meters to centimeters, and centimeters to millimeters. The first thing I always do, and here is a nice, easy thing to remember, right? So if you want to cut this out and put it in your notebook, you can. Absolutely fabulous. So here is kilometers, here is meters, here is centimeters, and here is millimeters. Now, these arrows and these multiply by 10 business and divide by 10 business, what do they mean? Well, they're just telling you what to do to go to each unit depending on which way you're converting. Now, I always remember there are 100 centimeters in a meter. So, meters into centimeters. There are 100, so I'm going to multiply by 100 going that way, and which means with mathematics, I would divide by 100 going the other way. There are 10 millimeters in a centimeter, so I'm going to multiply by 10 to go that way and divide by 10 by that way. Now, if you can't, the number of people who get millimeters in centimeters wrong staggers me. Guys, use your ruler. Your ruler is there to help you, all right? It's 10 little marks. It even probably says somewhere 10 millimeters equals 1 centimeter. Number of people who think there's 100. Okay, it's not. And I know there are 1,000 kilometers in, 1,000 meters in a kilometer. How do I know that? Well, kilo. Kilo means 1,000. So kilogram, 1,000 grams. Kilometer, 1,000 meters. And it's very, very interesting that we say kilometer. That's actually mispronounced, believe it or not. It should be pronounced kilometer. I know, weird, huh? And slightly stupid, but great thing about the English language is we somehow keep mispronouncing things and it becomes the standard. So this is the way that I always remember. I always start with meters, then I go to centimeters, then I go to millimeters, and then strangely I go back to kilometers. So long as you get this times by business the correct way around, you are fine. Then we get to perimeter. Now, perimeter is absolutely fabulous, and it confuses so many people. The perimeter is the length all the way around the outside of a shape. So, one of the most easy ones we tend to deal with, and I'm going to deal with here, is a quadrilateral. And because I've done those little signs on them, it must be a rectangle. So, generally speaking, we'll only give you two measurements. Let's say 4 and 10. We might tell you it's in centimeters. Units are really, really important. And lots of people do this in lots of different ways. Some people will go, okay, well, that's 4 centimeters and that's 10 centimeters. And they'll put a little cross in a corner and they will go 10 centimeters plus 4 centimeters plus 10 centimeters plus 4 centimeters. And I'm back to where I started. So what was that? 10 centimeters plus 4 centimeters plus 10 centimeters plus 4 centimeters is my perimeter, which gives me 14 plus 14, which is 28 centimeters. Other people don't. Other people say, well, I know it's a cuboid, and so I've got 4 centimeters and 10 centimeters. Add those two together and double it. Why double it? Because the shape is symmetrical around those, or, you know, it can be split up into two lots. So in there, they would have done perimeter is equal to 4 plus 10 times 2, which, strangely enough, gives you exactly the right answer. Now, maths being a big fat trick, will try and throw curveballs. And one of the best I happen to notice or always see is this one here. And what they'll say again is that might be, I don't know, 8 centimeters, and that might be 10 centimeters. And they say, find the perimeter. Now, what I need you to realize is that this is the biggest trick on the planet. The perimeter is basically saying, add all of the vertical lengths together and add all of the horizontal lengths together. So, first things first, I know the perimeter for that shape would be 8 plus 10, because those are 2 lengths. But what about all these staggery bits here, these horizontally bits and vertically bits? Well, look at all the horizontal bits. This little length here in red, this little length there in red, that little length there in red, that little length there in there, that little length there in red. What do you think they all add together? Well, it's a trick. Add all those together, and what do you notice? You get 10 centimeters. Why? Well, if I drag this line up to the top, and I drag that line up to the top, and I drag this line up to the top, and I drag that line up to the top, I'm just going to have this, which just so happens to be 10 centimeters. And if I drag this vertical line, and this vertical line, and this vertical line, this vertical line, if I drag them all this way, it's actually going to still end up giving me a rectangle. So I can add another 8 and add another 10, and I get 18, and I get 18, which is 36 centimeters in this case. Huge trick. And you want to look for these tricks all the way through. Now, just scrolling over, one of the other shapes they use all of the time is a triangle. All right, a triangle. So that might be 5, that might be 12. Now, in this situation, to find the perimeter, same rules apply. You have to do that length plus that length plus that length. Now, the difference between perimeter and area is that we all know the area is half base times height. It does not want the area. So to find the perimeter, we would have to find that length there. And being a right angle triangle, we would need to use that wonderful topic of Pythagoras Theorem to help me get the answer. So that's coming in a moment. Then we move to circumference of a circle. Now, the great thing about circumference of a circle is it's a formula. The formula for the circumference of the circle is either pi times d or 2 pi r. So I suppose the first thing is, what is d? Well, d is equal to the diameter of the circle. What is r? Is equal to the radius of the circle. And what is c? It is the circumference. Well, actually, as far as I'm concerned, the word circumference and perimeter mean exactly the same thing. And once again, Barry's been at it. I'm going to give him a name now. Barry's been at it. Barry is sitting in that office. He is alone. He has no windows. He wears a white lab coat, has bad facial hair. And he's decided, why not come up with a completely 2 different things to stand for perimeter, all right? Yep, circumference and perimeter, as far as I'm concerned, are the same thing. But circumference we use for circles. So as I say, first things first, if you have a circumference or you have a circle, they need to give you the radius, or they can give you this diameter. Now, diameter goes from one end to the other end of the circle, or from one edge of the circle to the other edge of the circle, and it has to pass through the origin, the center, whereas the radius goes from the center to any edge. And a small point here, maths is a trick. If I actually had a triangle, for example, like that, and I told you that that O was the center, lots of people don't know that that could be an isosceles triangle or an equilateral triangle. Why? Anything from the center to the edge is actually a radius. So that value there and that value there are exactly the same. Whenever you get a shape inside a circle, look for radii. List them, mark them, and I think you'll probably find that most of the questions are correct. So if I told you that radius in this situation was 5 centimeters, then I would use this formula here. Circumference is 2 times pi times radius, which is 2 times pi times 5, which is 10 pi. Now, you're going to say to me, why have I left it in terms of pi? Well, in many cases in maths, we want to have exact answers, and leaving things in terms of pi's or square roots or surds is an exact value. If you need to go off and actually calculate this and write your answer to 2 or 3 decimal places, you would obviously then use your value on your calculator, 3.159, whatever it is, to however many decimal points. Just always, always, always be careful to round to the correct number of decimal places, and that will be told to you in the question. Alternatively, if you're not sure, I don't think there's anything wrong with leaving it in terms of pi. Right, perimeter of a sector. What is a sector? As far as I'm concerned, a sector is a pie slice. Yay! Perimeter of a sector. So, normally speaking, in fact, in every single case, this value here will be a radius, this value here will be a radius, and that will be some form of an angle. So, to find the perimeter, you would need to take that radius and add them together. So, perimeter would be 2 lots of the radius. Add what? Well, we'd need to find this fraction of the circle. Oh, interestingly, I said the word fraction, and I said it for a very specific point. Because we don't have a whole circle, we have a fraction of a circle. And what do I know about the numbers of degrees in a circle? It's 360 degrees. Now, interestingly, I want that fraction of the circumference. Well, what is the angle? How much of the circle do I have? Well, it just so happens I have theta. So that is the fraction of the circle I have, but I want to have the fraction of the circumference. So there is my fraction of is times the circumference, which is 2 times pi times radius. Okay, so just again, this value here comes from my radius plus my radius. You cannot forget these. These are part of the perimeter of my sector, but then we need to find the fraction of the circumference that I actually have. Here is my fraction, here is my of, and here is my circumference. These type of questions come up in exams all the time, and they are flipping awesome. Right, that's the first bit done, 12 minutes. Wow. Review of Pythagoras' theorem. Go back to what I told you earlier. Here we go. There is my right angle triangle. I know that's 5, I know that's 12, and I want to find the perimeter. How do I find the perimeter? Well, I've got to find all the side lengths, and with a right angle triangle, I can use this fabulous thing called Pythagoras Theorem, which states c squared equals a squared plus b squared. Now, in the United Kingdom, that's a squared equals b squared plus c squared. Makes no difference, so long as you remember that the thing that's on its own is my hypotenuse. Right, so this value here is what we're trying to find. So I'm going to call it x, because x is always used in maths. We like that. So what do I now know? I know that x squared is equal to 5 squared plus 12 squared. With maths, we always try and make simpler what we can before we do the hard stuff. So in this situation, I can do 5 squared is 25. Remember, 5 squared is the same as 5 times 5. 12 squared is 144. So that's equal to x squared. Add them together, make it simpler before I do the hard stuff, is 169. So x becomes equal to plus or minus, and if you remember, when we square root, there are actually 2 values, a positive and a negative value. So x becomes equal to plus or minus 13. Now what that suggests is x can be equal to 13, or x can be equal to minus 13. Now, I don't know about you, but how on earth can a length of a triangle, or in fact any length, have a negative value? That doesn't make any sense to me at all. So I discount this value. I'm not interested in it. And that tells me that x equals 13. This is the review of Pythagoras Theorem. You need to know how to use Pythagoras Theorem in measurements because it's used a lot. Is that my final answer? No, because if you remember, they wanted me to find my perimeter. So I would do 5 plus 12 plus 13, which is 5, plus 25, which equals 30. Oh my goodness, they did not give me units. Well, if you don't know what the units is, you actually write the word units. That's my advice to you. Shows that you is clever. Shows that you is thinking about the fact that this is a measurement and they haven't given you a units, and as such, you must have units. With Pythag, just as a curveball, they may give you that, they may give you that, they don't give you that. Still a right angle triangle. Still, my advice to you every single time is write out the formula. Substitute in what you know. Remember, the thing that's on its own is always the hypotenuse. That's the one that the right angle is pointing to. You can actually make the right angle into an arrow. So, 5 squared is equal to, this can be A, it doesn't actually matter, and this can be B. A is now 4 squared plus question mark squared. 5 squared is 25, 4 squared is 16, I'm going to take away 16 from both sides to get the question marks on its own. So question mark squared is equal to 25 minus 16. That's equal to 9. So question mark is plus or minus the square root of 9, which is plus or minus the square root, which is plus or minus 3. And so therefore, question mark would have to be 3 units. Why? Why can't it be negative? Because when we think about our answer, well, we can't actually have a square root of a, we can't actually have a minus area. We can't have a minus length. What am I talking about? Last thing in this video is area consolidating. Units of area and conversion between the two. Lots of people get these wrong. You remember, earlier in this video we talked about meters into centimeters, and we said, to do that we times by 100, and centimeters into millimeters we go, we times that by 10, and then going back we go kilometers into meters, we times by 1,000. And lots of people think that you use the same rules for area, but you can't. Length is basically one-dimensional, but area, and we're dealing very much with area, is now two-dimensional. And what I'm saying is that when we actually have a length and multiply it by 1,000, it gets bigger in just one way. But when we have an area, if we had an area that was 1 meter by 1 meter, and we actually turn that into centimeters, well, think about what that now becomes. That becomes 100 centimeters by 100 centimeters. This here is 100 times bigger, and this here is 100 times bigger. So it's actually got bigger by a factor of 100 times 100. Huge! And that's the trick to being able to do the conversion of units of area. I always draw myself this diagram here, always, and I'll rub it out and start again just to let you know. I always start with, here is 1 meter by 1 meter. And if I want to go to centimeters, I go at 100 centimeters by 100 centimeters. To get from here to here, I've then had to times by 100 and times by 100 again. Why? That 1 meter there has had to times by 100, and that 1 meter there has to had to times by 100 as well. Well, that would suggest that if we were to now redraw, but this time do meters squared to centimeters squared to millimeters squared, and then just bang on the end here, kilometers squared. Well, to go from meters to centimeters, we times by 100. But to go from meters squared to centimeters squared, we times by 100 and times by 100 again. So is that the rule that we can use? Oh, yes. If for centimeters to millimeters, I times by 10. To go from centimeters squared to millimeters squared, I times by 10 and times by 10 again. Why? Because area is to the floaty 2. It's growing in 2 dimensions. So I need to times by 10 in 1 dimension and times by 10 again in another dimension. So what do you reckon kilometers squared to meters squared is? Yep, it's going to be times by 1,000 and times by 1,000 again. We can actually write this in a quicker way. So once again, kilometers squared to meters squared to centimeters squared to millimeters squared. Ooh, putting the other m in, and that is times by 1,000 squared times by 100 squared and times by 10 squared. And remember, when you square something, you're actually timesing it by yourself. So timesing by 100 squared is the same as times by 100 and times by 100. Wow, that's pretty cool. So you need to know this. Last thing for consolidation is areas of standard shapes. We know that a square has the area of base times height. Base times height. You need to know this. Likewise with a rectangle. There is my base. There is my height. So same for the thing. The area of a triangle. Everyone knows this one. And if you were watching me on video, which is coming soon, by the way, I'm going to start recording my actual self, adding them to these videos. You would know that the area is a half base times height. Some of the less used ones, but probably just as important, rhombus, right? So this is a rhombus. What do we need to know about a rhombus? Well, the area is a half x times y. What's this x times y business? Well, when you have the rhombus, and I'll draw it again, distance between one corner to the other is x, and distance from the opposite corners is y. So that is the area. All right? Oh, that's an awesome formula. Parallelogram, funny enough, is just a pushed over square. So the area there is base times height. Wow. Trapezium, I like this one, trapezium. My advice to you is always a plus b. I actually describe this as add the parallels, multiply it by how far apart it is. So this h is actually how far apart those two lines are. And not all diagrams are going to be drawn as the standard trapezium. And then once you've done that, half your answer. So add the parallels, times by how far apart they are, and half the area. Once again, a kite. Is this half xy business? Y? Well, there we go. That is your value of x, for example, and that is your value of y. It doesn't actually matter which you call x and y. It doesn't matter because we know that 2 times 3 and 3 times 2 are the same. Area of a circle. Coming up soon, we're going to need to use this. Is pi times radius squared. Now, what that tells you to do is find the radius, square it, and then times by pi. Do not do pi times radius and square your answer, because that is very different from the answer you'll get here. Take the radius, square it, and multiply it by pi. And area of a sector of a circle, once again, if we think about it, this value here is going to be my radius. This here is the fraction of the circle that I have. Well, if we know that the area of a whole circle is pi r squared, then we know the fraction of that circle is pi on 360. Sorry, not pi, theta on 360. So the area of that is theta on 360. Why? Because it is the fraction times is of the whole circle. Okay. Going to leave that one there, and during the next lesson we're going to kick in with surface areas of prisms and cylinders. Thanks very much for watching. I look forward to seeing you in part 2 coming soon. It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right. Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to see you again.